Today we are on day 3 of our proportional and linear relationships unit. So the first thing that I would like for you to do is find the unit rate for each person. So Grace is represented in the table, Pun is represented as a situation, Peak is represented as an equation, and Sophia is represented in the graph. So you're going to find the unit rate for each person. Make sure you show your work for that. And then you're going to decide who is walking the fastest. So pause the video, complete this warm-up, and then you can come back to the video. Okay, so hopefully you finished Walk-a-thon part 1. So we have a walk-a-thon, and walk-a-thon is when you're sometimes when you're trying to raise money. A read-a-thon, you would read as many pages as you could. For a walk-a-thon, you're going to walk as much as you can, and you get sponsors who are going to pay you for those things. So in this, Ms. Major's advisory is raising money for Second Chance Bangkok, and we're going to have a walk-a-thon. And so Grace, Pun, Peak, and Sophia have figured out their walking rate. They did this so they could make predictions about how fast they could walk. This concept, this skill, being able to find unit rates from different representations like tables, graphs, equations, and situations, and then compare them is one of the standards, and that's on an upcoming assessment. Okay, so if you did that, hopefully you found that Grace was walking 1 meter per second, and you can see the work there, the division problem for Grace. Pun is going 2 meters per second. Again, you can see his work. Sophia, there are 3 points that we could use from the graph to help us find her unit rate. The pink, green, and purple points with the matching work. And Sophia was walking 2.5 meters per second. And then for Peak, we need to recognize there's no work on paper, there's work in our brain to recognize that y equals kx is the equation for a proportional relationship. So k is 1.5, and that k, that constant proportionality, is the unit rate. So Peak would be walking 1.75 meters per second. And then just a reminder, when we're finding that unit rate, it is y per x. So we're taking the y, the meters in this case is on our y-axis, and per means divide. We're dividing by the number of seconds. So last class we talked about the difference between linear relationships, proportional relationships, and nonlinear relationships. So just to recap, Parvin's problem, this first problem, was a proportional relationship. We saw a straight line, so it's linear, and it also goes through the origin, 0, 0, which is this point here. And so because it's linear and passes through the origin, it is proportional. For Yasmin's puppy Maggie, that was a linear relationship. Linear, we saw a straight line when we graphed it, but it's not proportional because it doesn't go through the origin. And here's a really important connection to make. When we can find this unit rate, plates per minute, ounces per day, when we can find the unit rate, it is going to be linear. If it's increasing the same amount every minute or every day, that constant rate of change, changing the same amount each time, is what creates that straight line. So when we can find the unit rate, we can write an equation. For Angel's problem, number 3, it was not linear. We can look on the graph and see it's not a straight line. We have a curve. And then if we're looking at how much it's changing, plus 20, plus 40, plus 80. So the amount that it's changing by each time, the 20, 40, 80, is changing. So there's not a constant rate of change. The amount that it's changing is changing. So that one is non-linear. If we can find a unit rate, we know it's going to be linear because there's a constant rate of change. And then if it also goes through the origin, it is linear and it is also proportional. Okay, so one of the things that we want to look at is being able to write the equations for those problems with a unit rate. And one of the things that we've been talking about in class, if it's proportional, Parvin's problem was proportional. There was a proportional relationship. So if it is proportional, remember we are talking about the equation y equals kx. And remember, k is our constant rate of change, also our unit rate. In this case, it's 1.7 plates per minute. So k is equal to 1.7. So our equation, if we were going to write an equation for Parvin, would be y equals 1.7x. Okay. And then when we try and write an equation for Yasmin, if we think about what would happen if it were proportional. So let's just pretend for a moment that the puppy Maggie weighed 0 at birth. But let's say we know that she's growing 1.4 ounces per day. That's important for us. So let's still have her growing 1.4 ounces per day, right? So there, that would be my 1.4. This would be my 2.8, right? And we could keep going. We could draw that line. That's if it's proportional. And if it were proportional and we were thinking y equals kx, right, then that would be y equals 1.4x. But what that doesn't take into account is she didn't start at 0. She started at 14. And if we were to take a minute to look at if it's proportional and we looked at an xy table, right, if x is 1, we would have 1.4. Y would be 1.4, right? 1.4, if the equation is y equals 1.4x, 1.4 times 1 is 1.4. If x is 2, then 1.4 times 2 is 2.8. Okay? If we look at what happens, we know it's not proportional. We know that it's linear, so there's a constant rate of change. And we look at the x, y values in our table. When x was 1, yes, it increased by 1.4, but the total weight was 15.4. When x was 2, right, in 2 days' time, she grew 2.8 ounces, but the total weight was 16.8. So when we're looking at writing an equation for Maggie, what we have to consider, if we think about it like this, 1.4 and 2.8 is actually how much she grew, but then what do we have to do to those pieces to get to 15.4 and 6.8? Well, 1.4 plus 14 is 15.4, and 2.8 plus 14 is 16.8. And the reason that we're having to add 14, if we look at it graphically, right, this first point we had to move from 0 to 14. So our second point would move from like 1.4 all the way up to 15.4. So that is going up 14. Same thing, we go from 2.8 up to 16.8 because we have to add in that 14 ounces that she weighed at birth. So our equation kind of matches up with that. So it would be y equals 1.4x. That takes care of that constant rate of change that we have, plus the 14 pounds that Maggie weighed at birth. So this is what the equation would look like. So now we want to take a few notes on equations, because today you're going to need to be able to write the equation of a line. So these are important ideas for you to write down in your notebook. So if we're writing equations, if it's proportional, as we've mentioned before, that is y equals kx. And that K is our unit rate. So with Parvin and the plates, it was 1.7 plates per minute. And if it's linear, our equation is actually going to be y equals mx plus b. Now in this equation, right, we had like y equals 1.4x. So in the equation from Maggie, we had this y equals 1.4x, and that 1.4 was our unit rate. So in this equation, this time m is going to be our unit rate. And it's just like that unit rate that we used a K with, but K is the constant of proportionality. So we're only going to use K if it's a proportional relationship. But K and M show the same thing, that unit rate in the problem. 1.7 plates per minute, 1.4 ounces per day. And then we have this plus B part. And that plus B is like our starting value. Here's the important part, when x is equal to 0. For example, in that last problem, we're talking about her weight on day 0, and her weight on day 0 was 14 ounces, which is why we needed the plus 14, okay? And so if we're thinking about this, it's either going to be y equals kx, like that y equals 1.4x that we drew here. Or if it's linear, it's going to be y equals mx plus b, like that y equals 1.4x plus 14 for the actual problem for Maggie. Okay, so you're going to use those ideas of writing equations to help you with this next piece. And this next piece is the walk-a-thon. Walk-a-thon part 2. So my students in my advisory, they figured out how fast they can walk. They've made some plans, and they have gone out to get sponsors. And so those sponsors are pledging to give them money. And so Tess, she found a sponsor that's going to pay her $10 regardless of how far she walks. So if she went out and walked 50 kilometers, she's still going to get $10. If she got hurt and couldn't walk, $10 regardless of how far she walks, she's still going to get $10. So Tess is going to get $10 no matter what. Justin, his sponsor, is going to give him $2 per kilometer. So if Justin goes out and walks 10 kilometers, he's going to get $20 for his walk-a-thon. But if Justin got hurt and couldn't walk, he's going to get $0. And then Timmy's sponsors are going to make a $5 donation plus 50 cents per kilometer. If Tibby woke up and was feeling sick and she couldn't walk, her sponsors are still going to give her $5. If she came to the walk-a-thon and walked 1 kilometer, then her sponsors are going to give her the $5 plus 50 cents for that 1 kilometer, so they would give her $5.50. If she walked 2 kilometers, that's 1 more kilometer, so that's another 50 cents. So she would have the $5 donation plus 1 whole dollar, right? 50 cents. 50 cents would give her another $1, so now she would be at $6. So your job with the walk-a-thon, the first thing that you're going to do is to create a table. And you're going to put all of the data for all 3 people in the same table. So we have distance walked. I want you to start with 0 and go up to 12. That is the number of kilometers that they're going to walk. And then we have the amount earned by Tess in the second row, the amount earned by Justin in the third row, and the total amount earned by Tibby in the last row. And so if we go back to what we were saying before, if Tess doesn't walk at all, she still gets the $10. Remember, her sponsors are giving her $10 regardless of how far she walks, okay? If she were to walk 7 kilometers, guess what? She still gets $10. Justin, he's getting $2 per kilometer. So if Justin gets hurt, he doesn't get any money. If he were to walk 1 kilometer, remember he's going to get $2. And for every kilometer Justin walks, you're adding $2 more to his total amount earned. And then Tibby, remember, if Tibby gets hurt or she gets sick and she can't walk, she still gets the $5 donation. And if she were to walk 1 kilometer, remember, she's going to get 50 more cents, so her total would be $5.50. If she walked another kilometer, it would be 50 more cents, so $6 total. You're going to take a few minutes and fill out the table. And then when you're finished with the table, you're going to create a graph. And this is what your graph should look like. So in this case, the distance walked in kilometers is the independent variable. And the amount they earn is the dependent variable on the y-axis, because the amount earned depends on the distance they walk. Okay? You have 3 jobs. Your first job is to create the table in your notebook. Right? So you're going to copy that table down and fill it all in. And then the second job, you're going to create the graph. Again, so you're going to copy this graph down, and you should see 3 lines. 1 line for Tess, 1 line for Justin, 1 line for Tibby. And then the third thing that you're going to do, and that comes from part C, you are going to write an equation for each person. And so you're going to have an equation for Tess, an equation for Justin, and an equation for Tibby. But remember, when you do that, we are looking at either y equals kx or y equals mx plus b, where k and m are your unit rates, and b, if it's not proportional, b is that starting value when x was 0. So in this case, it would be the starting value for 0 kilometers. So table, graph, equation.